right, sounds good. Thank you. And all right, so I wrote this blog post about developer experience at American Airlines and how we've used the Kuma service mesh. And a lot of our strategy, I'm just going to pull up one other screen. A lot of our strategy has been around abstracting out the hard parts of Kubernetes and compartmentalizing the complexities and making it really easy to do the right thing through reproducible patterns for our applications. So we have at American Airlines developed a developer portal. Whoops, how did that jump back? That was weird. We've developed a developer portal based on Spotify's Backstage framework. We started really early on with the framework, developed unfortunately lots of technical debt that we're getting rid of, but we're really liking seeing the direction that the Backstage framework is going and keeping up with the latest and greatest now that some of the dust has settled. But being early adopters, we had to figure out our own ways to do a whole lot of things. So we had a whole lot of imagination right from the start. We wanted to make it really easy to, as I mentioned, deploy applications and make things easy from the start. So coming into our create application, we have a lot of different blueprints for our application teams to use. If I jump one screen, we've got application templates that deploy specifically to Kubernetes based on the tag that I've selected. All of our services that are launched into the Kubernetes platform that we have for our shared clusters do get added to our service mesh. We really try hard to, again, abstract that detail from our customers. We really don't want our application teams to have to worry about infrastructure, about connectivity, about networking, those sorts of things. We really want them to be able to just focus on their application code and what different items they might have to connect to. So through Runway, we can create new components. I've already kind of jumped through a little bit, filled in some American Airlines specific information, some repository information, and now I'm at the point to select the cluster and deploy my application. This will deploy a sample application out to our environment that users can then use as a base to grow from. However, we do have items to deploy an existing image from our internal registry out to our Kubernetes environment. Once teams do that and they go ahead and click next step and generate their application code out on GitHub, we have used the technology inside Backstage, again, as another abstraction layer to do continuous deployment through the Argo CD application and platform. Argo CD will watch repository files and then go ahead and update the Kubernetes deployment based on those files. If I continue on a little bit, I'll show one of the files from the repository that was created. So here's a test application I created yesterday with a Kubernetes directory and environment folder and what we're calling our web app YAML, another abstraction layer mentioned in the blog post. So with the web app YAML, we can simplify what is required to launch a Kubernetes application. We don't need deployment YAMLs or service YAMLs or ingresses or anything like that. In order to make Kuma work, we need to introduce the external service name. So again, our custom operator with our web app YAML is what we call it. It takes care of a lot of the complexities behind the scenes for Kubernetes itself. Kuma is not complex with setting up the external service, but it's one more step that we didn't want teams to have to worry about. We've also set up through our web app YAML and our Kubernetes operator, the Runway operator, standard traffic permission policies. And this one has an API permission policy applied. So through the Kuma service mesh and the traffic permissions, along with tags or labels on the Kubernetes resource, we can restrict what applications, what services can then communicate with this test application here. We've got other policies as well that are built in, such as deny all, that can stop all traffic from reaching an application within our service mesh. And then you can apply additional policies on top of that to allow specific applications to then communicate. But this ensures that we can provide some of those standard traffic permissions and allow teams extra capabilities without them having to set up their own API gateways or something similar like that. If I continue on to the next page, this web app YAML that we're seeing here, this is a live application out on my Argo CD instance right now. You can see that that web app YAML created external service while this is the normal service, and it looks like I haven't refreshed recently, but an external or a normal service, an external service, a deployment, horizontal pod autoscaler, ingress, and then all my pods associated with that. So for the service mesh, we can go from the ingress to the external service name and then continue our hopping through the service mesh as needed. So abstracting those layers out. When I look at the external service, we can see the .mesh URL, which works with the Kuma service mesh, and that's all automatically generated. As I continue on, as part of our Runway platform, we have our catalog that displays a lot of high-level dashboard type information about our application, about our deployment, about how it's running. So we can see the URL that's available for our developers to start using pretty quickly, as well as the mesh URL and information on how and what to use that URL for. The whole process for creating the Kubernetes resources, getting it registered into the service mesh, creating the Docker image, at least for this Python fast API application that we're using as a sample. The whole process takes about 6 minutes to get this URL fully responding out on the internet, protected by our security providers and CDN providers as well. So there's a lot of work that goes into all this automation behind the scenes to make sure that we're doing things in a security compliant way, that we're serving up our ingresses in a security compliant way as well, and we're protecting our resources. As I continue on, this is the application that's live out there. Again, it's an example, but it has our continuous deployment mechanisms built in. It has unit tests and other functionality built into the GitHub repo and different workflows to test code and make sure that we're doing the best we can for our applications. For the whole service mesh installation, we're doing everything through GitHub Actions with our clusters and with the Kuma installation for our global and our remote zones. Because of all of the GitHub action work that we've done, along with Terraform and Helm charts and everything else, we can set up an entirely new cluster environment with a service mesh running through all of our GitHub actions in probably about 30 to 40 minutes, depending on our cloud provider with their Kubernetes startup time and all. So we've got, I think, a pretty good system to automate things and make things really easy for the end user and not have to think about the complexities that come with Kubernetes and then have to learn service mesh technology on top of it as well. We plan in the future to continue enhancing this catalog screen with more information about all the components that are involved in delivering an application out to the internet, showing a full route, including the service mesh information, the policies as well, and then being able to abstract some of that policy application through Runway, our developer platform here. So those are the plans that we have going forward, and continuing to make the service mesh just really easy for all of our customers to use. We evaluated a lot of different service meshes, pretty much everything under the CNCF landscape. And with Kuma, it just made it really easy to install things, get going, and do things that could be hard, or you might have to add additional components with other service mesh technologies. Kuma just offered it right out of the box with batteries included. So we were able to get going, configure it, use some of the more advanced, well, maybe some intermediate capabilities and then moving into more advanced capabilities and do things really easily and very quick and iteratively as well. So I think that pretty much sums up what was in my blog post. We cover a lot of the abstraction layers and offer some more details and some images through the blog post. But as a whole, for the Kuma service mesh and the Runway platform and the customer experience, it's pretty straightforward and easy. Hopefully, Julia, that's what you were looking for. Oh.
Hey, thank you, Karl. This is Marco. Fantastic presentation. I have a few questions for you, and I'll start with the first one, really. What would you like to see in the project?
That's difficult. I think we've seen a lot of, I guess, documentation, updates and more examples and things like that. We had to work through some of that ourselves. But other than that, continuing to promote it through the CNCF landscape, getting more contributors and more involved in it. But specific functionality and feature set, I know that we utilize a not the same API management platform that you guys might use. And I know that they have an Envoy plugin, so maybe more information around how we can incorporate those sorts of plugins into the Envoy instance that Kuma's running could be helpful. But overall, the traffic policies and everything that's available has been super helpful. And then digging into the Slack channels has been really helpful as well, and getting help and support there. So
yeah, thank you.
Not a whole lot of enhancements that I can mention. Yep.
Okay, great. Well, we also have a couple questions in the chat. Some from Charlie. We have, how do you map your traffic permission short names to actual traffic permissions in Kuma? And do they end up being tags in your services?
So that is how we're doing it with when I showed this standard traffic permission. Here we're applying labels on the deployment itself. So when we want to route traffic through our, in this case, we use the Apigee API management platform and the Apigee micro gateways. When we go ahead and apply this traffic permission, we use labels on the deployment to then reroute traffic in specific ways to make sure it's going through that Apigee micro gateway. Does that help? Is that what you were asking?
Hopefully. Yeah, that answers it. Thanks.
Okay.
Okay, and then we have a question from Ilya. Are you using or planning to use any policies that improve availability, such as health check, circuit breaker, or retry?
So we do have the default retries in there. We do want to investigate the circuit breakers. We haven't had time to investigate that, and we are using the health checks as well.
Okay. If anybody else has any questions, feel free to unmute or drop them in the chat.
Yeah.
And for the, oh, go on, sorry.
How many zones and data planes do you actually run?
So right now in our non-production environment, we've got 8 different zones, and in our production environment, we have 5 different zones. And then data planes, not quite sure. I'd have to look at that.
I mean, an order of magnitude is probably fine. Like, you know, is it thousands, hundreds?
So in our non-production environment, it's hundreds. It's not in the thousands yet. I would say the last time I checked, it was probably around 600-700.
Okay, thanks.
In this environment that we're, sorry, Jacob, go ahead.
Yeah, maybe I will let you finish and then I will ask my question.
Okay. And just for order of magnitude and data plane, this platform, I would say, is still kind of getting up and going. It moved from the experimental phase kind of to more the adoptive phase. We're working with our customers to make sure that we can service all their requests and everything. So some applications that are out there are just kind of test demo applications, seeing what the environment's capable of. Others that we have out there, we actually have like at our gate agents that are using them on their iPhones and all their mobile devices and things like that. So there's, it varies as far as what kind of applications we house on this platform.
Okay, so going back to my question, do you run everything within one mesh, or do you use a feature of multiple meshes?
So we're going to, right now it's a single mesh. We're investigating adding additional meshes for different capabilities and different reasons. Right now we're heading down the PCI path and looking to see what our strategy is going to be around PCI applications and whether or not they're going to use the same mesh or different meshes, and then just continuing to go on through that path. But I think we've kind of only skimmed the surface of what Kuma can provide and do for us. And we're, as customer requests come in for different capabilities, that'll allow us to continue digging in deeper.
Okay, and what is PCI or what was the abbreviation?
PCI, and I'm drawing a blank on what it stands for, but like handling credit card data and
Okay.
customer information and things like that. So being an airline, of course, we run lots of different transactions with secure data, and we have different regulations that are required to handle that data.
Okay, and when it comes to policies, right now, do you only use traffic permission, or do you also use or maybe expose any other policies to user?
Exposing policies to users, the only one is the traffic permissions right now. We haven't had any other use cases for exposing any of the other permissions or any of the other policies to users. Within American Airlines, we've had the discussion a lot about service meshes in general and what the capabilities are. And it seems to be a hot topic, but it doesn't seem like a lot of our users have more advanced reasons for different policies and things like that. So as those discussions come up, we'll continue expanding.
Okay, okay, thanks.
We've got a question from Paul. What does CP hardware typically look like generally? CPU, RAM?
So we're using, for Kuma specifically or just in general, I guess the hardware, we're just using AKS clusters in Azure. So we're using pretty beefy nodes. I really couldn't give you what the specs are right now, though. We have different node pools based on system workloads, user workloads, different types of workloads. So we have different sizing techniques for that. I don't, if there's more information, maybe I can clarify more, but.
He said thanks, so I think that was good.
Okay. And we
Yeah,
auto
that's great,
scale
thanks.
everything. Okay. And we auto scale as well. So we've done lots of load testing for the different workload cases as well, to minimize the auto scaling. But again, it's, I don't know what the exact SKU is of most of our hardware. But with the service mesh and with the different abstraction layers that we've chosen as well, specifically like our Rancher platform that we're using to abstract out the user management, our goal is to be able to expand to other cloud providers much more easily. And then use the Kuma service mesh to help us out with that as well. And then use the locality aware load balancing. Our whole plan when we moved into Azure, there was a whole lot that you had to set up, and specifically from a user permission perspective, but through using the Runway platform, we've started moving some of those user permissions, at least for Kubernetes and application deployments, over to the Rancher platform as our management layers, so that when we want to move to another cloud provider, we can simply add those clusters. We can then use our Argo CD platform to onboard the applications. We don't have to really deal with user access management in the different cloud providers, and we can just move much more quickly. And Kuma helps with that as well, because we can find our applications wherever they might be. We do have other items that are mentioned in our blog here over on Kong, such as our Runway Kubernetes operator. That helps us for our GTM provider, because that will relay any new ingresses that come up on our clusters out to our GTM provider. And that doesn't run on every single cluster. That just has an instance or two within our service mesh. So we also save resources there by doing minimal deployments in different localities, and then having the service mesh be able to help us with that discoverability, and making sure too, because not all of our services are available through the internet, such as our GTM sync services, and then just being able to route that easily through the mesh, and then the American Airlines private network is a huge benefit as well.
Looks like we have a question from Ilya. What Kuma version are you running? Is it easy for you to keep up with the upgrades?
We're at 1.3.1 right now. I know with 1.4.0, there's the new authentication method. Or the authentication changes. So we are going to continue to stay current and upgrade. We just haven't upgraded to 1.4.0 yet. And I thought 1.4.1 was out, so hopefully we're not too far behind.
Hey, Karl, this is
oh, go on.
Oh, sorry, go ahead, finish your point.
I was just going to say, we do use Argo CD when possible to keep applications in sync. We haven't looked to use that for Kuma quite yet, but that's probably going to be something that we explore. I don't know how that's going to interact with upgrades and the fact that Argo CD is polling every once in a while, but should be something interesting to dig into. Sorry, John.
No worries. I was, this is not specifically a mesh question, but I mean, this is a fantastic use case and like a great presentation. I'm really interested in general in like abstraction layers on top of Kubernetes. So I'm curious, when did you decide to make that leap to writing your own operator and creating your own CRDs? Like, what were the kind of factors that went into that decision? Did you already have the technical expertise to do that? Or was it really driven by the user experience you wanted to provide? Like, I would love if you could talk on that a little bit.
It was really around the user experience we wanted to provide. It was around the fact that we had some new management come in, some key players in the DevOps space. And one of the challenges was being able to describe your application in 10 lines of YAML or less. And I don't think we quite got there. If you take out the environment variables and the standard traffic permission policy, maybe a few other things, we could have gotten quite close to that. But the whole goal was to make it really easy for teams to describe their apps and get it deployed. So that is where the custom operator came into play. That's where we already had the Runway platform. We already recognized a problem internally of all these application teams having to reinvent the wheel every time that they were deploying an application and creating an application. So creating a lot of these abstraction layers to help our users out made a lot of sense. And it also makes a lot of sense too when you consider the velocity technology is moving at, because through these abstraction layers, we can swap out things behind the scenes without our teams really knowing about it. So if we want to swap out the operator or change how deployments happen or change the tags or things like that, we can easily do that. And because of the Kuma service mesh, when we enabled locality-aware load balancing, in order to do that, there's a label, last time I checked at least, that you're supposed to apply to the deployment that says what region you're in, so that you can do locality-aware load balancing. And with the operator, we take the node labels, read the node labels as far as what region we're in, and then we apply that to the deployment, so then Kuma knows where all of our applications are. So we were able to, without teams having to go fill in that information, we were able to do that behind the scenes without them really knowing about it or having to care or worry about it, using our operator. Using Argo CD, we wanted to take away some of the hassles of having tokens and credentials and GitHub repos and things like that, to deploy through actions. And when I say secrets and repos, of course, I mean in the GitHub repo secrets, not in code. But so from the start, all the abstraction layers, it was all about just trying to make a really easy customer experience and trying to make something that's typically really difficult on teams and hard to know all the YAML that's required, just make it really simple.
That's awesome. Do you provide a level of break glass functionality if a team has that knowledge and wants to punch through and do other things, or is it like a very kind of strictly curated experience?
So with Argo CD, at least, teams are able to supply straight Kubernetes YAML if they wanted to. I don't know if there's any teams that have done that yet. Our operator deployment has kept up with customer needs and requests pretty well. But overall, they could do that. We do have security mechanisms, though, in place at various levels to stop teams from doing kind of things that they shouldn't. And we don't run Calico on any of our nodes. And one of the safety points to ensure that we're able to stop traffic if needed is to ensure all of our pods have a Kuma sidecar. So we don't actually allow any of our applications in our cluster to run without the sidecars. We have policies implemented with a policy engine to ensure that. So there are different kinds of restrictions we implement to make sure certain components are used, and that we can do things like traffic permission policies to stop traffic. But otherwise, we're open to user experimentation and open to different requests that we get and trying to implement those quickly. I hope that helps.
Awesome. Cool. Thank you. Yeah, it does.
Cool.
Great. We are at the end of the allotted time. Do you have time for 2 more questions, Karl, or should we answer those offline?
I do have to go in just a minute or two, but I can answer 2 more questions.
Okay. Charlie mentioned that in the summit talk, you were about to experiment with on-prem VMs. I guess
I can't. It's hard to hear you. I'm sorry. It sounds a little garbled. I don't know if it's just my side. Hopefully I sound okay.
No,
but
yeah,
I did.
I think the question was about on-prem VMs. In the summit talk, you mentioned you were going to experiment with those. I guess that's Kuma Universal Mode. Have you experimented with that yet, or are you still in planning?
So we haven't had a use case yet. So a lot of our work is all around use cases, and we're moving more away from VMs and creating VMs and moving more towards Kubernetes. Our IT vision is app portability. And from our standpoint, Kubernetes is the technology that is preferred and offers that. So no, we haven't tried it, and we're reducing our reliance on VMs and creating new VMs as well.
And then can you hear me better now?
I can't, but I can read the question, which is around the gateway question. What kind of policies at the edge do you employ? So we are kind of policies?
Like transformations, security, that kind of stuff. I'm just curious.
Specifically around the Kuma service mesh?
Yeah, like as requests come in and get into the mesh, are you guys using some kind of heavy duty Apogee stuff?
We're not, because not everything coming into the service mesh requires Apogee. It's actually very little at this time. We're still seeing what our strategy is and what the capabilities are for app teams. So we're not doing a whole lot at that layer. Everything comes through our security provider, which is Akamai. So Akamai has a lot of different policies that they implement.
Sure.
And we implement network security rules at the Azure level to ensure that all of our traffic comes through Akamai. So we already have that layer with them.
Cool. Thanks.
Yep. Cool. Well, thanks everyone for the questions. I appreciate it a lot. And thanks for checking out what we're doing at American Airlines.
Thanks, Carl.
Thanks. Have a good rest of your day.
Good stuff. Thank you.
Thank you, Steve.